This is lesson 6-6, systems of inequalities. So for this lesson, we're actually going to combine two things that we've done previously. We started in, I believe it was lesson 5-6, last chapter, chapter 5, and we graphed inequalities. And remember, we had to decide if it was a dotted line or a solid line, and then we had to shade our graph above or below. So we have that. Then in chapter 6, very first lesson, we talked about graphing systems of inequalities. So we have two different equations, we graph them both on a coordinate plane, and wherever they cross each other, if they cross each other at one spot, that's the solution. They might lie directly on top of each other, then that would be infinite solutions, or they might not touch each other at all, and that's no solution, right? So now we're going to combine those two ideas, and we're going to graph systems of inequalities. We're not getting any further into it. This is the last lesson in chapter 6. You're not going to have to do a whole lot with systems of inequalities other than graph them. That's it. So don't overcomplicate it for yourself. Okay, so systems of inequalities. The solution to a system of inequalities is the set of all ordered pairs that satisfy both inequalities. If you graph the inequalities in the same coordinate plane, the solution is the region where the graphs overlap, okay? So solve the system of inequalities by graphing. Here, we have a system of inequalities, and over here to the side, they've been graphed. So we're going to get down here at the bottom, and we're going to graph our own, and you'll see how it works. But see this little region here that's like darker, right? We shaded this line above, we shaded this line below, and where they overlap, those ordered pairs are the solution. All this stuff in this area, right? And then you're like, well, great. How do I say that? You don't have to say. You don't have to write that anywhere. You don't have to physically write it out. All you have to do is graph it and show, make it really dark where they overlap each other, that this is the region that holds all the answers. And you're done. That's it. It's that easy. Okay? Another thing that might happen is you could have parallel lines, and they can either be shaded in towards each other, or they can be shaded out away from each other, or they could both be shaded in the same direction, right? So we're just going to have to get into, we have 6 problems down here to graph, but hopefully this gives you an idea of, these are what your graph should look like. 2 lines shading above or below both lines, and you should have a region of overlap. Okay, so I'm going to zoom in a little bit here. I'm going to use a yellow highlighter and a pink highlighter so that hopefully where they overlap it looks orange. Okay, so first we're going to start off graphing y is greater than -1. So on my y-axis, I go down to -1, put a dot. My inequality symbol does not have a line under it, so my graphed line is going to be dotted, right? And when I have just y equals a number, that's a horizontal line, right? You got to go back and brush up on graphing if you're not real strong with it, because we're putting a whole lot of things together for this lesson. So y is greater than -1. I'm going to draw a dotted line across -1, and I'm going to shade everything above it, because remember, y is the shaded region. The shaded region is greater than the line. So it's everything up this way. Okay, that's my shading. You can use a pen if you want. That's fine. I'm trying to make it stand out here. Okay, then our second line, x is less than 0. So here on the x-axis, I go to 0, and I draw a vertical dotted line. Can't really see it on this graph, but it's supposed to be a dotted line through x equals 0, right? And x is less than that. So which direction are all the numbers smaller than 0? This way or this way? This way, right? So I'm going to take my pink marker, and this is my dotted line. You just can't see it because it's on the axis. And I'm going to highlight everything this way, right? So the solution to that system of inequalities is this little region right here where the two graphs overlap their shading, right? So somehow on your paper, whether you used colors or whether you just, shade, and wherever they overlap, you make it extra dark, I don't care. The solution is the darkest overlapped shaded part. Okay, hopefully that's making sense. Let's do another one. First, y is greater than -2x plus 2. remember to graph this, you're going to think of it as y equals negative 2x plus 2. So on my y-axis, I go up to plus 2, and I put a dot. My slope is negative 2 over 1, so I'm going to go down 2 over 1, put a dot. Down 2 over 1, down 2 over 1, right? That's what my line's going to look like. I do have a ruler here to use a straight edge now. And my inequality sign does not have a line under it, so it's going to be dotted. And then I have to shade, right? And do you remember what to do if you don't know whether I'm shading? Oops, I know it's so far down. If I'm not sure if I shade this way or this way, do you remember what to do? Pick a point and plug it in and see which way it works, right? So I always pick 0, 0. So if I plug 0, 0 in and it makes this a true statement, then I know this is a solution, so I'd shade this way. If I plug 0, 0 in and it's not correct, if it doesn't work, then I know I don't shade that way, I shade this way, right? So 0 is greater than, this becomes 0 plus 2. Is 0 greater than 2? No, 0 is less than 2. So 0.00 here does not work. So I have to shade this way. I'm trying with my pen this time. So I'm going to shade this inequality. If you don't remember about graphing inequalities, go back to chapter 5. I believe it was lesson 6, 5-6, and that's all graphing inequalities. Okay, then I want to graph the second one. Y is less than or equal to x plus 1. So I start off at plus 1. And then my slope is the number in front of x, which is 1, so 1 over 1. So I'm going to go up 1 over 1, put a dot. Up 1 over 1, up 1 over 1, up 1 over 1. Okay, and this symbol does have the line under it, so it's going to be a solid line when I graph it, when I draw it. Not dotted, it's going to be solid. So I'm just going to draw a solid line. And it says that the shaded region is less than the line, right? Well, which I don't, is that this way or this way? I don't know which way less means, right? So I'm going to pick this point 0, 0. When x is 0, y is 0. I'm going to plug it in and try it. If it works, then I shade this way. If it doesn't, then I shade the other way. So 0 is less than 0 plus 1. 0 is less than 1. Is 0 less than or equal to 1? Yeah, that's true. So I'm going to shade this way. And I'm going to make my pen strokes go in the opposite direction so that it stands out when they overlap, right? So see what I mean? Here's the little area where they overlap. It's all of this. This region is where the two graphs overlap each other. So just make sure you make your shading really clear. You don't have to write out what the answer is, nothing else. You just literally have to graph it. So I just need to see where the overlap part is. The overlap part is all the solutions that solve both inequalities. Okay, let's do another one. Y is less than x plus 1, up to 1, put a dot. My slope is 1 over 1, up 1 over 1. And then it does not have a line under it, so I'm going to make it a dotted line. I'm going to find you a straight edge, especially in these systems of inequalities, because it needs to be pretty precise. Okay, and I'm not sure which way to shade, so I'm going to start with 0.00 right here. 0 is less than 0 plus 1. 0 is less than 1, so yes, that works. So I'm going to shade this direction. I'm going to use yellow. I'm going to shade all of this. Okay, and oh, sorry, I'm hitting this all over the place. And then the other equation, 3x plus 4y is greater than 12. All right, well, that's in kind of standard form, right? So I'm going to think of it as 3x plus 4y equals 12. And if I want to graph standard form, I can find the x and the y intercepts. So to find the x-intercept, I plug a 0 in for y and solve, so that goes away. And I get 3x equals 12, so x equals 4. So on my x-axis, I go over 1, 2, 3, 4, and I put a dot. Now I want to find the y-intercept. So to find y, I plug a 0 in for x, and that goes away. 4y equals 12, so y equals 3. So on my y-axis, I go up to 3, and I put a dot. So I know I'm going to connect these two dots. I'm going to draw a line through it. And my inequality symbol is solid because it has the line under. So I'm going to connect those two dots with a solid line. Okay, and then I need to know which way to shade. I don't know if it's up this way or if it's down this way. So I'm going to pick 0, 0, and I'm going to plug it in, right? Plug it into this guy. So this becomes 0, this becomes 0. 0 plus 0 is greater than 12. Is 0 greater than or equal to 12? No, it's less than or equal to 12, but it's not greater than or equal to 12. So that's not true. So 0 doesn't work. So for this line right here, I'm not going to shade this way. I'm going to shade up above with my pink color. And you can see right where they overlap. I'll do that in orange. Okay, so a few things you need to make sure are very clear. Don't make your lines all curvy. Don't get sloppy. I'm telling y'all, when I grade, here, let me show you real quick. Flip this over. Oh, shoot. Okay, if I'm grading your paper and there's a graph and your straight lines look like this, and it's kind of shaded like this, and then shaded like this, or whatever, like that, no, that doesn't cut it. That is not a graph. You need to have your coordinate plane with straight lines. I need to see exactly where your two lines cross. I need to see crisp coloring inside the lines. You cannot be sloppy with this. What I have here is about the sloppiest you can be with it. You need to be thorough. Okay, number 4, we got 3 more here. 2x plus y is greater than or equal to 1. X minus y is greater than or equal to -2. So both of these lines are going to be solid. They're both in standard form. To graph standard form, you can put it in slope intercept form if you want, but then I got to fool with changing my sign around. I don't want to do that. So I'm just going to graph standard form, you just find the x and the y intercepts. So to find the x intercept, to figure out where my line crosses x, I got to do something with y, right? So I get rid of it. I just plug a 0 in, that's it. So I get rid of y, and now I have 2x. When you're finding the intercepts, the sign doesn't matter. So 2x equals 1. So divide both sides by 2, and x equals 1/2. So I cross the x-axis here at this half. And then to find y, I plug a 0 in for x, so that goes away. So y is at 1. All right. So I got my line there. I know it's going to be a solid line because of my inequality symbol. There's 1. And I got to figure out which way to shade, right? So I'm going to pick 0, 0 right here, plug it in, see if it works. Plug a 0 in here, 0 in here, 0 plus 0 is 0. Is 0 greater than 1? No, that doesn't work. So I'm not going to shade this way where 0, 0 is. I'm going to shade the other way. Shade all the way up to your line. Don't leave a big space. Don't get sloppy. You can go back and go over it, whatever you got to do, but be thorough. This is the fun part. It's like big kid coloring. Just kidding. All right, and then the other equation, I got to find my x and my y intercepts. So to find x, plug a 0 in for y, it goes away. So x is at -2. And then to find y, plug a 0 in for x, so the x just goes away. Y is at -2. Okay, and I know it's going to be a solid line, so I connect those two dots with a solid line. All right, and then I got to figure out which way to shade. So I'm going to pick 0, 0, plug it in here. Is 0 greater than -2? Yes, it is. So I'm going to shade this direction, right? I'm going to shade everything this way. Pretend like this other graph isn't here for a second. I'm just graphing this one line inequality. Okay, so this line shaded this way, and then this second line shaded everything this way. So where do they overlap? All of this. All right, so make the overlap part really dark and clear. This is the overlap. Okay, Number 5. X is less than 2x plus 3. I'll start there. It's a solid line. This other one's a solid line as well. So I start off at 3, go up 1, 2, 3, put a dot. The number in front of x is 2, or 2 over 1. So my slope says go up 2 over 1, starting here, up 2 over 1. And it's a solid line, so I'm going to connect those 2 dots and draw a solid line. And then I get a shade. I'm going to use my marker. Doesn't matter how you do it. I don't care if you use colored pencils, crayons, just your pencil and worry about shading, highlighters. I don't care, as long as it's clear to me. And then I don't know which way to shade, if it's backwards or forward, so I'm going to plug in 0, 0, see if it works. 0 for x, 0 for y. So I'm going to have y is less than 0 plus 3. 0 is y. 0 is less than 3. Is that true? Yes, it is. So I'm going to shade where this point is. If you're confused because I'm talking that out and going kind of fast with it, let me know, and I'll private message you like a little picture showing you where I got that. It's an easy concept, but I'm saying it so fast that if it didn't click yet, I know it's probably just going to be confusing. All right, and then I have the second line, also going to be a solid line. Y is greater than or equal to negative 1 plus 2. Let me just remind you here that when we write slope-intercept form, it should be written as 2x, that's positive 2x, and then this negative 1 goes at the end, so minus 1. To think of it that way when you graph, right? So our y-intercept is negative 1, so I go down here, put a dot, and my slope is 2 over 1, so up 2 over 1. Hey, that slope is the same as this other line, so they're going to be parallel, right? Parallel solid lines. Boom. They're supposed to be parallel. Mine aren't perfect. And then I got to figure out which way to shade, so I'm going to put 0, 0 into this inequality. 0 is greater than negative 1. Is that true? Yes, it is. So for this line that I just graphed, I'm going to shade everything up this way, including 0, 0. Okay, so for the top line, I shaded everything down. For the bottom, for this right line here, I shaded everything up. So they overlap in between. So make sure you make that clear. In this region is all the ordered pairs that solve both inequalities. Okay, and last one, I hope this is making sense for you guys. Last one, I've got a standard form equation, ax by equals c, and a slope-intercept equation. So I want to graph both of these. If you don't remember how to graph, you need to go back and review that or ask me for help on graphing, because it's really important you're comfortable with that. All right, 3x minus 2y is less than 6. I am actually going to, never mind, I'm not going to. I'm going to do x and y intercepts. So if I want to find the x-intercept, I'm going to cover up y. 5x and equals 6, just think of it as an equal sign. 5x equals 6, divide both sides by 5, x equals 6 over 5, which is just a little bit more than 1. So on the x-axis, I'm going to go a little bit past 1 and put a dot. And then to find my y-intercept, I plug a 0 in for x, it goes away. Negative 2y equals 6, so y equals negative 3. So I go down to negative 3. My symbol does not have a line under it, so it's going to be a dotted symbol. A dotted line, not symbol. And I'm kind of guesstimating right where it goes. Dotted line, and then I got a shade. And I don't know which way direction to shade, this way or up this way. So I'm going to pick 0, 0 right here, and I'm going to plug a 0 and a 0 in and see if that works. Okay. So 0, this becomes 0, this becomes 0. 0 minus 0 is 0. Is 0 less than 6? No, 6 is greater than 0. So I'm going to shade down this way, the opposite direction. Okay, and then I need to graph the other equation. y is greater than negative x plus 1. If you're using a pencil, another great way to shade is to smear it with your finger. This is a pen, doesn't work. But if you use a pencil, it's awesome how the lead, like, you know what I'm talking about? That's really good for shading. That's what I should have done. Oh, well, that's okay. All right, so shaded this way, then I have y is greater than negative x plus 1. This is slope-intercept form, so I start off with the plus 1. And then my slope is negative 1 over 1, so I'm going to go down 1 over 1, down 1 over 1. And this is also a dotted line. So I'm going to connect these lines. And I don't know which way to shade, up or down, so I'm going to plug 0, 0 in here. 0 is greater than 1. Is 0 greater than 1? No, that doesn't work. So this can't be an answer, so I've got to shade everything up this way. So I'm going to shade it in the opposite direction of the other shading. Right, shade everything on my graph this way. So the area of overlap is, my pen is too dark and I've like written over my line. I can't see my line now. It's this area, right? And really it's infinite. It's everything this way. This line keeps going, this line keeps going. So this entire region here where the two graphs overlap, all this is the answer, but we're just kind of limiting it to just where our graph kind of stops, right? So that's where we shade. But theoretically, it does keep going on and on forever. It's infinite. Okay, so I hope that makes sense with the grading and the shading. You're just basically graphing two different inequalities on the same graph and trying to see where they overlap, if at all. And that's your solution. And as far as writing your solution, you don't have to write it. You're literally graphing and the picture is the answer. You're done. Okay, so let me know if you have questions.